In this section, we're going to talk about symmetry of graphs, and we're going to look at reflective symmetry and rotational symmetry. Here's an interesting fact at first. Is your face perfectly symmetric? They say that the more aesthetically pleasing people are to look at means they have a nice symmetry around their line of symmetry on their face. Now, where is that line of symmetry? If we look at Angelina Jolie here, if you cut her right down the middle, and if you were to take the right side of her face and flip it over and repeat it, she's going to be very symmetric and look almost the same. Same with Brad Pitt. You take his face and you split it right down the middle. They'll say he's aesthetically pleasing to look at too because his face is so symmetric. Now this is just kind of a fun thing about symmetry. Here's Justin Bieber, and what somebody actually did on this, if you take it as original picture, they took his face and they cut it right down the middle. They took the left-hand side of his face right here, and then they flipped it over, and here's what he looks like. They then took his right side of his face and did the same thing and flipped it over. You can tell here that the images of himself are very similar to his original face. This was also done with Taylor Swift, so cutting her face right down the middle. This is the left side of her face replicated and the right side of her face replicated. Again, both of these people look very similar to their original picture, therefore they say they are aesthetically pleasing to look at. Well, let's do Learning Objective A and talk about the symmetries of the graph. The two types of symmetries we're going to talk about in this entire book is reflective and rotational of 180 degrees. Reflective is if a figure can be mapped onto itself by a reflection over some line, and it's called the axis or the line of symmetry. So if we look at something here that we're used to seeing in math class, this is an absolute value graph, so it's y equals the absolute value of x. This does have a line of symmetry. And if you cut right down here in the middle on the y-axis, which is the equation x equals 0, we can see that if we take this side of the graph and flip it to the other, we get this side, which gives us the original graph. So it has reflective symmetry over the line x equals 0. Now, rotational symmetry means a figure can be mapped into itself under a rotation of 180 degrees around a particular point, and this is a point of symmetry. So this one you're going to have to imagine a little bit differently. If we were to take this equation here, which is y equals 1 over x is the equation, and if you hold it steady right here, if we hold that steady and we rotate the graph around that point like a pinwheel that you would see at a carnival, what's going to happen is this original graph, as you rotate that part after 180 degrees, it will actually land right here, and it will look like its original self. So for this graph, we would say it has rotational symmetry around the point 0, 0.